everyone, welcome to this week's recitation video. Today we're going to be discussing databases using the SQL programming language. It is going to be a mix of easy and just a lot of parts because there's a lot of combinations that you can do with SQL. This is going to be our second to last recitation. Next week's recitation is most likely going to be a review for the final exam and just like a prep video. Or if you guys don't want a video, then I could have like extended office hours, or you can just like send me your questions, email me, whatever you want me to do for the next week's recitation video. Okay, so other than that, announcements, you have Assignment 10 that's due December 8th, and the quiz is also due Friday. And if you didn't see my announcement already, I posted an announcement with a link to the SIRS survey, and it's just a survey where you like rate the class and rate the professor. So that is worth 2 points extra credit, so I suggest you do that. Other than that, let's get started. Okay, so what is SQL? It stands for Structured Query Language, and it's going to be different from JavaScript or HTML that we learned before because it's designed for manipulating databases. So when I say manipulating databases, there's these four main operations. It's called CRUD. Create, read, update, and delete. So those are the main operations that you're going to be doing with SQL to manipulate databases and getting certain types of data that you want out and then just leaving the rest. Okay, so what is a database? So this should be kind of simple. It's just an organized collection of data and it's stored electronically, and that's why we kind of started with Excel first, so you kind of get an idea of what a bunch of data could look like, and then now we're going to start querying it down using SQL. Okay, and the types of databases. So there are multiple types, and we're going to be working with relational databases. Relational meaning they're stored in tables and they're connected to each other in some way. I'm going to talk about how they're connected to each other later. It's through their primary keys and secondary keys. But that is what basically SQL uses to query through databases. There's also non-relational databases. It's not something you have to know, but I just put it down here in case you guys were interested. Okay, and how do databases work? So it's not directly you or the user talking to the database. There's this thing in the middle called the DBMS, which stands for the Database Management System. And this DBMS is where the SQL queries go through, all the CRUD operations go through to get or receive data. So in this little picture over here, this is the different programs for insert, delete, update, and querying. So let's say you want just a table about the number of students in your class. You would write a SQL query. It's going to go to the DBMS. DBMS is going to read that. It's going to go and get exactly what you want and then give it back to you. So you're basically communicating with the DBMS rather than the database. Okay, so before we get started into the actual practicing, there's certain commands you have to know because this is a different type of programming language and it works a little bit differently. So some basic SQL commands. You can have select, insert to, update, and then the next slide is going to have some more. So select is anything you want to get from a database. You want to get a column with the grades for the class or the names of people in a book or something like that. You're going to do this format over here. So you can have select and then the different columns or fields and then from the name of the table. So you can select the first name, last name, and from the users. So we're assuming this is the table name. Now there in SQL when you're writing, you don't have to make all of this uppercase. The keywords can be lowercase. It's not case sensitive. Just make sure their spelling is correct. So it's not going to be as strict as JavaScript or HTML. As long as like the spelling is correct, it should go through. Okay, insert into. So if you're adding in new data, you're going to insert into the database, or sorry, the table. And the way you do that is this format over here. You put the keyword, then you're going to have the name of the table, and then what columns you want to insert the values into. So let's say in the users table, I want to insert the first name and the last name. Then I'm going to reference those columns, and then the values are going to go in that exact order. The first name is going to be John, and the last name is going to be Doe. So notice how it has these single quotes around the values that's referencing back to a string. So when you have text input, you're going to refer to it with quotes, most likely single quotes for your SQL. And it's going to be in the exact order. So think of like parameters when we're working with JavaScript. Your parameters have to be in the exact order they were in the function. So here, when you're referencing the table with the certain column names, you're going to have the values in that exact order as well. It's going to be John for first name and Doe for last name. If you switch it up, then it's going to put like Doe for first name and John for last name, and then that's going to mess it up. Okay, the update command. So it's going to modify existing data within a table. So let's say like there was a primary key that was set incorrectly and you want to change it. Then what you're going to do is you're going to use update keyword, have the table name, and you're going to do update set and where. So you're going to update something, you're going to set it, that's going to be the new value, and then where is going to be the condition. So for this one, we're going to update the user's email wherever the user ID is equal to 1. So we're going to go through the table, find the user ID, first that column, we're going to search for 1, and then in that row, we're going to set the email field to john@example.com. Okay. And let's continue. Delete and union. So delete is pretty simple. It's just going to remove data from a table. So let's say you want to remove a certain column. Let's say you want to remove that guy we just talked about. This is John. And his user ID was equal to 1. So wherever his user ID is equal to 1, you're going to remove from the user's table. So that means it's going to take out everything according to that user ID. And last but not least, union. So when you have more than one select statement that you want to put together and they have similar data types, that's when you're going to use union. So here you're going to do select first name from users and then union select name from customers. Notice how they're both the similar data types, meaning they're both can be strings. It's first name and the name, they're both referencing strings. So that has to be similar for you to use union. Okay, so what we're going to do is going to go to this program is online SQL compiler. So normally you would download SQL Workbench or something like that, but because this is like their second to last recitation, we're not going to go deep into SQL. It's just getting the highlight of it, so we're just going to use an online compiler. And you're just going to go to this link, and we're going to talk about the different parts in this online compiler. So let's move this over here. Okay, so this is an online SQL editor or compiler, whatever you want to call it. And what this does is it has a little editor where you can input your SQL code. It has an output section and then already has some pre-made tables available for you. So these are the tables that they already made for us. And then this is just another way of displaying what's inside the table. So first things first, this is how you make a comment in SQL. You're going to do 2 dashes. So what they did up here, do 2 dashes, and then you write whatever you want. So comments are like just things for you to know. And then here is where you can put in your SQL code. And well, let's go back to the slide so we can continue with some examples. Okay. So what we're going to do is we're going to create a table. So we have some existing stuff, but we want to create some more stuff. So we're going to create the table merge customer and country. So now this is going to be available in the database.txt file that I posted on Canvas in the recitations 13 folder. So you can just copy paste it from there. And I'm just going to go over some things when you're creating a table. So as you can see, there's uppercase C and a lowercase c here. You can use either, you can do all caps, as long as the letters are the same, like the spelling is correct, you should be fine. And then inside, you're going to have these different fields. Fields meaning the column names. So customer ID, first name, last name, age, country. And then after it, or next to it, you're going to put the data type. So customer ID is going to be an int. Int is a number. Now, varchar with parentheses of 100. That means that varchar stands for variable characters. So the number of characters that are going to be stored here. And here we're just assuming it's going to be 100. This number is kind of like up to you, whatever you think is the minimum storage needed. And that's only for like strings. So country, last name, first name. For age or customer ID, you don't need it. That's just going to be an int, and that doesn't need a size. So what you're going to do is go to database.txt, and we're going to copy one at a time. So copy this, and delete everything from here, and we're going to paste. And then press Run SQL. And it's going to add the merge customer table here, and then it's going to say the result set is empty. Now that is true, because we didn't actually add data to this table. We just mentioned what are the different column name, the table's name, and the types. And then what we want to do is we want to add the second table. So we're going to delete and put this in. We press Run. Now it's going to add the country up here. So it is going to go alphabetically, I believe. And this is also going to be empty. So I'm going to give you a second to do that. Okay, so once you have that done, we're going to move on because we already created our tables. Now we're going to append to tables. By appending, I mean adding. So when I mean adding data, I mean using the insert into operation. So this is also going to be in the database.txt. First, we're going to insert into merge customer. So we're just going to copy all of this. And then we're going to put it in here. And notice right now merge customer is empty. Now next I click this, it should add in the data. So Forrest, Mickey, Jelly, Ben, and Rudolph, those should be all added in. And then let's do filling into the country. And then the country table should be updated at the top. So that so far is fairly simple since we just copy pasted everything so far. Now is where it's going to get not so complicated, but a little bit more in-depth. So we're going to have like little practice questions, and I'm going to go through and kind of explain different types of queries and different things you can do with the table. So let's say you want to select all the entries in the merge customer database. So there's a couple keywords just in the question that helps us answer it. You want to select, meaning we're going to use the select keyword. They told us the name of the database, so we're going to be using from merge customer. The only thing we have to figure out is the all entries. Now to select all of something, the shortcut is to use this star. So you can do select star, and that's going to be shift and then the number 8 from merge customer. So select star from, and then you run, and it will display all of the merge customer table. It's basically going to display everything in there because we did not ask for something, just one column or one type of data. We asked for everything in this table. Now that's going to be our output. Let me just make this a little bit bigger. Okay, I don't think that really helps. Okay, whatever. Let's select specific entries, in this case, all entries whose age is less than 46. So we still want to go from the merge customer table, but we want a specific data where the age is less than 46. So we're going to still use select, and we're still going to go from merge customer. So it's going to be this same thing, because I still want all of the entries, so we still use a star, but then we're going to add to it. So we're going to say where age is less than 46. And this is the where keyword that we're going to be using. So let me just say where age is less than 46, and then you just press run. And now you can see that age is 44 and 34, so those are both less than 46. Okay, so now what happens if we do select first name, last name, country from merge customers? So that's kind of self-explanatory. So it's still going to go from the merge customer table, and it's going to only select or output all of the values of first name, last name, and country. So it's going to show all those entries, but just those columns, meaning it's not going to show age, it's not going to show customer ID. So let's just run that as well. Select country from merge customer. Is that exactly what they want? Okay, so first name, last name, and country. Notice it's not displaying customer ID, and it's not displaying age. Okay, what happens if we do select first name, last name, country from merge customer, where country is equal to USA? So basically the exact same thing as the one before. The only update is the country has to be equal to USA. So that's very self-explanatory. So it's going to show values of the country being USA, but it's only going to display first name, last name, and country. Where country is equal to USA. So there it is. Okay. Now this last one, it's going to be talking about primary keys, and I'm going to explain more about it in the next slide, but primary key is basically a unique identifier, and it says fix the duplicate customer ID so that we can merge the customer tables and maintain a primary key on customer ID. So I'm going to show the answer and then kind of explain through. So when we want to merge the tables, we're going to do update merge customer, and then now we want to change the customer ID because that is the primary key. So when you want to change something, you use set and then where. So you're going to set customer ID equal to 6 where it was previously equal to 5. Now customer ID right now, basically what they want to do is change this 5 into a 6, and that's all that is. Now if I go deeper into primary keys and secondary keys, this is very important, and this is why it makes a relational database into a relational database. So a primary key is like a unique identifier, and a unique identifier is kind of like if you go back to HTML when we had each input tag and they had an ID. The ID had to be something completely unique from any other variable, and it could not be repeated. It has to be unique for just that tag. Now this is very similar. This is a unique identifier for each row. So like if you had a table named students, each student would have a unique student ID. Like 101, 102, 103. It's like for us, like I have an ID which no one else is going to have. And the main purpose of that is to maintain uniqueness, and let's say, you were searching for something, you can use the primary key. Secondary key doesn't have to be unique, and it's mostly for faster searches and indexing, and doesn't have to identify a specific record. So let's say you have the students table, so a random table called students, and you have a field named course. When I say field, I mean like a column. So multiple students can be enrolled in the same course, like all of you guys are enrolled in computer applications for business, and that can be used as a secondary key. So let's say I want to find, let's have a table of students of all the people enrolled in Rutgers, but I want to find all the people enrolled in CS 170. I would use the secondary key, which would be filtering through the courses. Okay, So I'm hoping that makes a little bit more sense on primary keys and secondary keys. But we're going to move on. So let's say you're working with more than one table. So we're just going to copy paste this code. This code, I do not think it is on the database.txt, so these slides should be posted. You can just copy paste from the slides. So you're just going to copy this, and then we're going to put it into program is. And this is just a comment at the end, meaning after you do this, you want to clear it. And you might run into an error, meaning this one says error, no such column Judy, and that's just because sometimes when you copy paste, the quotes don't actually match up to the opening and closing quotes, so you might have to replace those yourself. So right now you can see that it added mini molitos. I don't even know what that is, but it added that to merge customer, but it didn't add Judy Hopps because the quotations were a little off. So just be careful when you're copy pasting things from database.txt into program is, it won't exactly translate sometimes. So now since we already have the first one, we can just delete it, and then we can just put in Judy Hopps. So now Judy Hopps from Zootopia, that should be in. Now let's say we want to do something more with this. So what happens if we do select from merge customer and the country, where the country is equal to the country CD. So now, like, see how there's like these random other things that are added in here? Those are variables that are used to easily reference that value in the table. So if I want to select from the merge customer table where the customer country is equal to the country CD, this is basically what it says. Select entries in merge customer who have countries listed in the country table. So now you can put this in to program is, and it should display that exact result. I'm just not going to do it for the sake of like being a waste of time of me trying to copy paste and show something that you can already do on your own. Okay, so let's just move on. What happens if we do select from customers and then union select from merge customer? So like I explained before, union is when you want to put two tables together. So this is just going to merge the customers table and the merge customer table. And then for those of you that wanted a little bit more complicated practice, I added this. And this covers a little bit of what the assignment talks about too. So here we have the not in keyword, and then it has like a nested select statements or nested queries. So we're choosing customers where the customer ID is not in, and then we're doing another select statement. So like it's a little bit more complicated. There's two simple select statements, but we're doing where one is not in another. So you guys can go through those, whoever wants to go through like the more complicated examples. But I'm just going to leave that there. And we're just going to move on to SQL functions. Okay, so like Excel, like JavaScript, we also have functions separate for SQL. And it's the basic ones like average, count, first, last, max, min, and sum. And these are just going to return a single value. And I'm not going to actually work with these. These are more of like kind of explaining because, finding the max of something is pretty self-explanatory. So let's look at the first example. Select all the entries from the merge customer table where the age is equal to, and then select max age from merge customer. So let's see what that does. New person run. Now it gave us a row of data, and it says Forrest Gump, age 55, country USA. So let's see where that is. That is in the merge customer table right at the top. So now why did it give us this exact one? Because we asked for the max age from the merge customer table, right? That is what this statement is doing over here. Select the max age from merge customer. So what it did was look through merge customer. It found the max age was 55. And then this statement said select all the entries where it's equal to the max. So right now the max is only one of them, so it's only going to have one output. Let's say there was like more than one values with 55, then it would display all of those as well. Okay. Now, next one. Select from merge customer where age is greater than, select a max of age from merge customer -10. Now, this one's a little bit more complicated because we're doing a little bit more math in here. So we run. And now we have 3 different entries. We have Forrest Gump, Big Ben, and Snow Rudolph, or Rudolph Snow. So now why these 3? The customer ID is 8, 11, and 5, and mainly we're looking at the age. So let's start with the nested select statement. Select the max age for merge customer. Okay, so that is 55. And then let's say you do where the age is greater than that. But before we go to the greater than that, they said -10. So 55 minus 10 is 45. Now we want anything greater than 45. So that is going to be 50, 50, and 55. So now those 3 values are all displayed because they wanted everything that was greater than 45, which would be these 3. Okay, so maybe rewatch that if some of you didn't understand it, because there's multiple parts and you want to go kind of backwards from the most nested part and then go a little bit outwards. Okay, select customer ID and then the sum of the amount from orders and then group by customer ID. So this is a new thing that we're adding here, is this group by keyword. So group by, what that does is basically instead of presenting your output in a random format of however it got it from the table, it's just going to make it a little bit more organized when it displays it to you. So if we run this, the main part, or the new part that was introduced for this example, is this group by customer ID. And when I say group by, it's going to just assume I want ascending order, and then you just go, well, you can see when it displays it goes in ascending order. And then the actual calculation that's happening in here is it's selecting the customer IDs and the sum of the amount from the orders table. So if we go to the orders table, it's displaying this amount. And now it's using the sum function on it, meaning it's adding up all the amounts, but there's nothing to really add because there's only one amount for each customer. Sorry. There is one amount for each customer except for customer ID with 4. That one has 400 and 300, so here it displays 700. Everything else should be the same because 1, 2, and 3, those only have single amount values. Okay, in this last example, select country and count the customer ID from merge customer and then group by country. So if we try that, it's going to group by the country, and now from the merge customer table, this is what we're displaying. So let's go to merge customer over here, and it's displaying the country and the count of the customer ID. So country, this one, and by count of customer ID, it's showing how many people or how many customer IDs are from UK, which would be 2, and let's check. UK is displayed 2 times, so it's counting the number of UKs and then displaying that number here. So USA is 3 times, and it's displaying the number 3 here. ES and Zootopia is 1, so that's just being displayed once. Okay, so that should... Oh, actually, never mind, one more. Okay. Cross-product notation. So this is most complicated that it's going to get, and it's cross-product notation for any of you guys who already did a little bit more complicated math. It's known as cross-join or Cartesian product, if that rings a bell. But basically, let's say we have this code section right here. Select from the orders O and shippings S, where the O.item, meaning the orders.item, is equal to mouse, and the s.status, meaning the shipping.status, is equal to pending. Now, all that's doing is joining two different tables together and finding values from there. So here, it's looking for each item from orders that is equal to mouse and has the status of pending. And if you actually do this command in Programmers on the compiler, it should give you 3 different entries as the output. And now for the next one, select all the entries from the orders O and shippings S where O.item is equal to mouse. What that means is it's going to return 5 different entries, because there should be 5 if you actually do it in the Programmer's compiler. It should be 5 different entries that have the item is equal to mouse. Okay. And that is just like a simple explanation of cross-join and Cartesian product. Now there was like a lot of things that were covered in here, and it's probably one of my longest recitation videos. So I suggest you go back, look through lecture notes, and maybe rewatch the video. Do some of the more complicated examples. That should like help you give an idea so you don't really struggle on the assignment. So let me just go over the assignment for you guys. This is going to be due December 14th, and you're going to be submitting a zip file. So just make sure you guys submit properly, because, you know, if you guys don't submit exactly what you're supposed to submit, I can't really give you guys extra time or extra chances to submit, because it's like literally the end of the semester. So, okay, so the beginning part is going to be self-explanatory, because they give you like screenshots on like what to do and everything. But like once you go to the end, over here where you have to actually write the queries of those, they're going to give you links of more examples and more ways to do it. A lot of this is what we covered. It's just going to be a more complicated version of it. So there's things like nested queries and filtering, and the primary key, joinings, things like that. Overall, it is like a more complicated version of what we covered in recitation. So just go step by step, and then I'll come to office hours or lab hours if you have questions. But other than that, that's it from me. Have a good day, and I'll see you next week. Thank you. Bye.